notes on 7.1 and 7.2. These notes, they're either going to be a little bit long or a little bit fast, so I apologize if they're long. I also apologize if they're fast. Some of this stuff I think you guys are going to pick up very quickly. You've seen stuff like this before, so that's why it may go fast. If the explanations take longer, obviously the video will get longer. So if you need to take a break, hey, take a break. You're in charge of you. Chapter 7 is all about polynomials. So in chapter 7-1, we're going to look at multiplying polynomials, and in 7.2, we're going to look at dividing polynomials. That's why they kind of go together and they kind of go quickly. So first, just some terminology. A monomial is a number, a variable, or a product of any one or more variables with non-negative integer exponents. Okay, it has only one term in the formula to calculate the horsepower of a car. This right here, this whole big giant junk of a thing right here, that is a monomial. It's just one term. Lots of numbers and letters, but they're not separated by a plus or minus. Okay. A constant is a monomial that's a real number. Also, sorry, skipped right here. Any expression with a variable in the denominator, that is not a monomial. Okay, so no variables in the denominator, no plus or minus signs, and you've got yourself a monomial. So if we take a look at these down here, very simply, determine which is a monomial, right? Yes or no. This one's a yes because it's just a number. This one's a yes, it's a plus sign. This is a yes, it's a number with an exponent. This is a yes, it's a single variable. Take a look at the guided practice. We'll do these together just to make sure everybody's on the same page. This is a yes. This is a yes. This is a yes. This one right here is a no. It's got a variable in the denominator. Okay, that's really it. So you guys know from previous classes that 3 to the 4th just means 3 times 3 times 3 times 3. Okay, this is the base, this is the exponent, these are called factors. We also use the word power sometimes. You guys know all that, okay? We're all very proud of you for knowing that. So we can apply some things, the definition of a power, so we can find the product of power. So say I want to know what's 2 times 2 to the 2nd times 2 to the 4th. Well, 2 times 2, and then multiply that by 2 times 2 times 2 times 2, all we have to do is add the factors. So what we discover is when we have the same base, and we see the same thing right here, 4 to the 3rd times 4 to the 2nd equals 4 to the 5th. What we discover is that when we have the same base, and that's a really important thing, guys. We have to have the same base. This is an A, this is an A. If that's true, we can just add the exponents when we multiply. So b to the 3rd times b to the 5th is b to the 8th. G to the 4th times g to the 6th is just g to the 10th. Now sometimes we have coefficients out front, like here, so we multiply. You look at this problem a little bit at a time. First, 6 times 2, and that's how we get 12, and then 3 plus 7, and then that's how we get n to the 10th. Really no problem. 3 times, this is a 1, so that's just a 3. We have to know that this p right here, we don't write to the first power, but it is a 1. So p to the 1st times p to the 3rd, we add those, that's p to the 4th. And then t to the 3rd times t to the 4th is t to the 7th. Take a second, pause the video right here, try and do 2a and 2b. Go ahead and pause the video now. Pause it. All right, you're back. Let's get some answers. 3 times 7 is 21. 4 plus 5 is 9. Okay, no problem. Here with 2b, negative 4 times negative 6 is a positive 24. Okay, positive 24. And then r to the 1st times r to the 5th is r to the 6th. X squared both times, so that's x to the 4th. And t cubed times t to the 1st is t to the 4th. Okay, pretty simple. Then we want to talk about products of powers. Okay, and so we have 3 squared to the 4th. So that's 3 squared times 3 squared times 3 squared times 3 squared. Well, that's just 2 plus 2 plus 2 plus 2. And so we get 8. So what we notice is that this is multiplication. Power to a power means we multiply. So when we raise a power to a power, we multiply the 2. Pretty simple, pretty simple. So here, 2 cubed squared to the 4th. Work our way inside out because of the grouping symbol. So 3 squared, 2 cubed to the 2nd power is just 3 times 2, so that's 2 to the 6th. Then we multiply again, we get 2 to the 24th, and that equals 16,777,216, or the amount of dollars in my bank account when I retire, God willing. So let's take a look at here. Go ahead and pause the video here. Try and get 3A and 3B. I'd like it as a number with an exponent and then calculate how much that actually is. Go ahead and do that now. All right, you've unpaused. Hopefully here you got 2 to the 16th, aka 65,536. And then over here you got 3 to the 12th, also known as 531,441. Okay? Now, we can use product of powers property and the power of a power property to find the power of a product. Peter Piper picked a peck of pickled peppers, something like that. So, here's what I mean, is we're going to take this and we're going to apply it to some problems to demonstrate the property for the power of a product. Again, 2 things inside and we're taking the power of. And basically what we're saying here is that everything inside the parentheses, the exponent applies to everything in the parentheses. So right here on this example, if it's 2yz squared and that whole thing is cubed, then it's 2 cubed, y cubed, z squared cubed. It's each part cubed. So if we look at this geometry problem right here, we know that area equals pi r squared. And so if I tell you that the radius is 2xy squared, well, then we're going to take 2 squared, which is 4, x squared, which is x squared, y squared, which is y to the 4th, and then multiply that by pi. We don't actually need to multiply it by pi, so we can leave pi as a part of the answer. All right, so here's what I'd like you to do. Express the area of a square with sides of length 3xy squared as a monomial. So 3xy squared is monomial. And then 4b, express the area of a triangle, 1/2 base times height. Express the area of a triangle, 1/2 base times height, with a height of 4a and a base of 5ab squared as a monomial. So multiply those out and get them as monomials. Pause the video here and try that. All right, you've unpaused. Here we have 9x squared, y to the 4th. And here we have 10a squared, b squared. If you didn't get either one of those, good Lord. If you didn't get either one of those, make sure you make note of it, and we'll be sure and go over that problem next time I see you. Here, simplifying expressions, you always want to just get things as simply as you possibly can. Make sure that each variable appears once, make sure that there are no powers of powers, and make sure that all fractions are in simplest form. That's always, you always have to do that, okay? This is just a big mess of an example saying that, all right, we're going to take power to a power, and then power to a power, and then we're going to multiply the products of powers, and then we're going to clean that up, and we're going to simplify everything the best we can, and we're going to get an answer. What I'd like for you to do is go ahead and try number 5 right down here. Try that on your own. Pause the video and try that. All right, you've unpaused. Hopefully you got 32, a to the 6th, b to the 10th. If you got that, raise your hand. If you're raising your hand, that's kind of funny because you're by yourself. Okay, we're going to take it second right here, or you can come back to this at the end if you want. Go ahead and pause the video. I know this is a lot, but some of these are really, really fast. Go ahead and try some or all of these 20. If you just want to do the odd ones, we can check those in class, that's fine. But try some or all of these 20. I would make sure I did the word problem if I was only doing odd. Okay, but you can pause the video here, try some of these, and then we'll come back to this in class, or you can do it at the end. That's it for 7-1, though. That's multiplying. Dividing works basically the same way, except for it's the opposite of multiplying, so some of the things are the opposite. So, for example, quotients of monomials, when we multiplied, we added. So, future detectives of America, when we divide, we subtract. Okay, when we divide, we subtract. So, g to the cubed over g is just g squared. H to the 5th over h squared is just h to the 3rd. No problem. Okay, go ahead and pause the video right here. Remember, divide means subtract. Go ahead and give me some answers to 1a and 1b. Pause the video and get me those. All right, you've unpaused. Hopefully here you got xy cubed, and hopefully over here you got k squared m to the 7th. All right? If you didn't, make sure you make a note of that so we can check them in class. We can use product of powers rule to find the powers of quotients for monomials. The way this works is 3/4 cubed is just 3 cubed over 4 cubed. And cd squared is just c squared over d squared. Okay, it's pretty simple. If it's a fraction in parentheses here, and we're taking that to a power, then the power applies to both the numerator and the denominator. It's not really complicated. Take a look here. This is 3 squared, p cubed squared, and 7 squared. So we do all that, and if we can, we reduce. If we can't, no biggie. Okay, go ahead and pause the video right here. Give me some answers to 2a, b, c, and d. Go ahead and pause the video here. All right, so let's check our answers. For 2a, hopefully you got 27 x to the 12th all over 64. For 2b, hopefully you got 25 x to the 10th y squared all over 36. For 2c, hopefully you got 4y to the 4th all over 9z to the 6th. And for 2d, hopefully you got 64 x to the 9th all over 125 y to the 12th. All right. So it says here a calculator can be used to explore expressions with 0 as the coefficient as the exponent. There are two methods to explain why a calculator gives us a value of 1 for 0. Here's what I'm going to tell you. I might walk you through this in class, but if you think of it like this, 3 to the 5th over 3 to the 5th is 3 to the 0, and anything to the 0 power equals 1. Another method of seeing it right here is 3 to the 5th over 3 to the 5th, and that equals 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3, so they all divide out to 1. I think there's an even better explanation to it. Whoa, sorry about that. And that is that if we look at a pattern, if we just look at like 2, for example, if we have 2 to the 4th, 2 to the 4th equals 16. 2 to the 3rd equals 8. 2 squared equals 4. What's the pattern? Hopefully you notice that each time it's being divided in half. So 2 to the 1st power equals 2. The pattern continues. So divide 2 in half, and you get 1. Anything to the 0 power is 1. Okay? So, next. Any non-zero raised to the 0 power is equal to 1. So it doesn't matter what it is. This whole big ridiculous nonsense right here, 1. So that's one kind of problem. That's just all of that, 1. Then here we have x to the 5th times y to the 0 over x cubed. Well, y to the 0 is 1, so that's gone. X to the 5th times 1 is just x to the 5th. Then we divide those, so we're subtracting the exponents, and that's x squared. Okay. Let's take a look here at this one. Here we have b to the 4th over b squared, so that's b squared. C squared over c, so that's c. And d to the 0 is just 1. That's a b, good lord. So all we need is b squared c. This whole ridiculous thing raised to the 0 power, 1. That's it. Okay. Negative exponents. So we can have negative exponents. Okay. When we subtract, we get c to the negative 3rd. If we look at it as division, then we have the 2 on top divide to 1, and we have 3 left on the bottom. I think there's another explanation. If you go back to what we had earlier, with 2 to the 4th being 2 to the 16th, 2 cubed equals 2 to the 8th, 2 squared equals 2 to the, sorry. Whoa. 2 to the 4th equals 16. Sorry about that. 8, 4, 2 to the 1st is 2, 2 to the 0 is 1, 2 to the negative 1. Well, if we continue on our pattern, we're cutting 1 in half, so that should be 1 over 2. If we continue on our pattern again, this should be half of a half is a 4th. And 1/4 is the same as 1 over 2 squared. So what happens when we have a negative exponent is it moves to the other side of the fraction, okay, and keeps the same power. So, for example, 2 to the negative 4th is 1 over 2 to the 4th, which is 1/16. 1 over j to the negative 4th, now it moves up to the top, is j to the 4th. So when it has a negative exponent, it moves to the other side of the fraction. So let's take a look at what that looks like in a problem. So here we have n to the negative 5th, p to the 4th, and r to the negative 2nd. The ones with the negative exponents are going to switch sides, and it's sometimes, I think this is a really good way of looking at it, is just split them into 3 separate sort of problems. This switches to the denominator, this stays where it is, and this switches to the numerator, and then we rewrite, and that's it. The problems can get harder when we add other numbers, so 5 over negative 20 is equal to negative 4, so we have our negative and our 4. Then we have r to the negative 3 over r squared. I think when there's some on the top and the bottom, it's easy to think of it as sort of like a tug of war. If there's a tug of war between the top and the bottom of the r's, and the top has negative 3 and the bottom has 2, then the bottom is going to win, and they win by 5. So it's r to the 5th on the bottom. Here with the t's, t to the 4th up top, t to the 7th on the bottom is going to win here by 3. Okay? And then we have u and no u up top. So this is -5, so the top actually wins by 5, even though this is u to the 0. They win by 5, so that goes right up there, and it's u to the 5th. Okay. Here, similar again, just more complicated, just more numbers and letters. Let's take a look at some of these practice ones. Okay. If we have v to the -3rd, well, there's no v on the bottom, so I know right away that v to the 3rd is on the bottom. W and W, they divide out to 1. Okay. Y, there is no y on the top, so that's y to the 6th up here. And x squared, there's no x anywhere, so the x just stays. And that's it. Okay. Go ahead and pause the video here. You try and do 4b and 4c on your own. Pause the video now. All right, hopefully for 4b, you got 8 over a to the 11th, b squared, c squared. And hopefully for 4c, you got k to the 6th over 5 j cubed m to the 4th. If you didn't, make note of it and we'll go over them. Okay. Order of magnitude is used to compare measures and to estimate and perform rough calculations. The order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, if we had 95, this is, let's see, billion. Order of magnitude says that that's just 10 to the 11th. Okay? We're just rounding things to the nearest 10. So if we look at this real world problem with magnitude, we round everything to the tens. The ratio of a man's height to the ant's height ends up being 2,125, which is 10 cubed. It's just for rounding purposes. We don't use this a whole lot. If you see this problem, what they've done is the average height of a man is close to 1 meter, so that's 10 to the 0. The average height of an ant is about 0.001 meters, so that's actually 10 to the -3rd. And then we say, well, how much bigger? You know, how much bigger are they? And we get 10 to the 3rd up top. So the ratio of the height is 10 to the 3rd. They gave us exact, but again, we're rounding to the nearest 10. So this 1.7 becomes 10 to the 0, and this 0.0008 becomes 10 to the -3rd, and we use those in the problem. We don't use this a whole lot, but it's worth taking a look at. So the order of magnitude of the mass of Earth is about 10 to the 27th. The order of magnitude of the Milky Way galaxy is about 10 to the 44th. How many orders of magnitude as big as the Milky Way galaxy as Earth? So how much bigger? And when we multiply, when we divide, we subtract. So the answer here is really simple. It's 44 minus 27, which is 10 to the 17th. Okay, it just wants to know how much bigger. Here's some problems for you to try. Again, if you just want to try the odd ones up here, but then make sure you do 18 because it's a word problem. And that's it for the notes, guys. That's it. I know it was a lot, and this is a longer video than usual, but the rules kind of repeat themselves. We'll get a lot of practice with this in class. I will see you next time. Bye.